We were on section 5.1. I forget what we were talking about. Oh, the box plot in the inner quartile range. Another way of showing the spread of the data. First, you need to know what frequency is, and then you can use a histogram. The number of times a variable in a data set takes on a certain value or a certain range of values, it's called the frequency. So like these values, we could see this one 64.8 comes up twice, so its frequency is 2. But you could also use a range of values, maybe from 59 to 63. There'd be 4. So a frequency can either be within a range of values or it can be one specific value. Like for mode, whichever one had the highest frequency was the mode. A histogram is a graphical representation of a frequency table. It's a chart with adjacent vertical bars. Each bar represents one entry from the frequency table. Its base on the x-axis is the intervals, and the height is your frequency. We did bar graphs. I don't think we looked at histograms, but bar graphs don't touch where a histogram does because it's continuous numerical values. To find the interval, you need to decide how many intervals you should have. One way of choosing is to find out how many pieces of data you have. And in this case, there's 25. And these are the heights that we've used before. I think they were the height of students from the previous problem. But there was 25 of them. So to see a good value of intervals, you take the square root. And the square root of 25 is 5. So 5 intervals. If you end up with a decimal, you can choose either way then. If we took the square root, say it was 26, and you take the square root of 26, you get 5.09. So you could use 5 or 6. So we're going to use 5. Using the heights, again, find a histogram. Decide the number of class intervals and take the square root of the number of data, which is what we did. Now to find out what you'll count by, it's the range divided by the number of classes that you want. In this case, it's 5. Remember, the range is the largest minus the smallest. Now, your book says to use 2.6, but you should use integers whenever possible. So you should round up. Even if it was 2.1, you need to round up. Otherwise, you may not get all of your higher integers or numbers in. So whatever this value is, you round up, unless it's an integer. So we want to count by 3s. To include this, I would go to 59. You want to use an integer. You wouldn't want to use 60 because then this value wouldn't be in your histogram. So you have to go down. So this would go down to 59. Then we count by 3s. 59, add 3, 62. Now this continues because they're overlapping, they're touching. 62 plus 3 is 65. 65 to 68, 68, 71, 71 to 74. So I just took this down to an integer, and then I counted by threes. Any questions? Now, when you're finding your values, this group or frequency is 59 up to, but not including 62. 62 goes into this one. If you want, you could think of it as 59 less than or equal to X less than 62. The 62 is in the next one. So there's 2. $62 up to, but not including 65. Would be these. And there's 8 of them. $65 up to, but not including 68. 1, 2, 3, 4, those 5. Any questions? Notice the 68s, they do not go into this one. They go into the bar after. 68 up to, but not including 60 or 71, which would be 1, 2, 3, 4, 5, 6, 7. 71 up to, but not including 74, but there isn't a 74. There's 3 that go in here. Any questions on that? Make a histogram. This is our heights. And this is our frequency. And our heights are these units. So it starts with 59, 62, 65, 68, 71, and 74. I'm going to count by twos. For the frequency. Really only needed to go up to 8. So this first bar from 59 to 62 is 2. The next one goes up to 8. And then 5, 7, and 3. And that would be your histogram. Any questions? The mean of a set of numerical values is the sum of all the values of the sets divided by how many there are. So you add all of them up and divide by how many there are. This symbol means to sum. So for the thing, you could go, you add up all the x values and you divide by how many there are. N is your sample size, and this means to add up all of the x values. It's a shorthand that can be used for the mean. And the mean is the average, and that's why it's saying you could use average height, average temperature. So mean is average. Along with mean, we use a measure called standard deviation, kind of like our range and the interquartile range and the normal range. It shows a spread of data. Well, the standard deviation also shows a spread of data. Now here they show you a shortcut for finding an estimate. I will also show you on Desmos how to find the exact value. We won't learn the exact value by hand because it's just long and it's not something you need when you can find it on Desmos or use this estimate. So the standard deviation, the estimate is 0.74 IQR. I wrote it over here. There's the data set. So the mean, let's find the mean and the standard deviation. Now we found, I think we found the IQR earlier. But the mean, the first thing you want to do is add all of them up, and then we'll divide by how many there are, which is 25. Maybe we didn't do that one. We'll do it on here. So first, to find the mean, and a symbol they usually use for mean is either X with a line over it or mu. This is when it's a sample. So we want to add up all the X values and divide by how many there are. If we add all of them up, we get 1660.2 divided by 25.
You added them up that fast?
When it doesn't specify what to round to, rule of thumb, you should go one more than your data. So since the data's to the 10th, I would go to the 100th. So the average is about 66.41. For the standard deviation, they either use an S or this symbol. And formula said 0.74 IQR. And this is approximate. IQR, remember, is the inner quartile range. It's the upper quartile minus the lower quartile. So we need to find the quartiles. There's 25 pieces of data. So if we take 25 minus 1, we get 24. Divide that by 2. There's 12 on each side of the middle one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 on each side of this number. So this is the middle number. That's your median. The lower quartile is the median below this value. Since there's 12 of them, 1, 2, 3, 4, 5, 6, right in the middle here. There'll be 6 on each side. So since it was an even value, we have to find the middle of the 2 middle values. So the lower quartile is 63.9 minus 63.3 divided by 2. The upper quartile, again, there's 12 of them. 1, 2, 3, 4, 5, 6. Right here would be the middle. There's 6 here and 6 here. So the upper quartile would be 69.6 my. Did I put minus? This should be a plus. I was still thinking about the range. Make sure this is a plus because you should get a number in between. $63.6. Sorry about that. Make sure this is a plus sign. I was just looking at the minus. $69.55. So these are our 2 quartiles. We need to find the inner quartile range by subtracting them. And we learned this part last class. Any questions? 5.9. Yes. So our standard deviation is the 0.74 times 595. So that would be an estimate for our standard deviation. Um, Let me show you this part first, and then we'll go to the Desmos and do it. A normal distribution is a bell-shaped curve that gives a good approximation to the distribution of many natural observed values. A normal curve usually resembles this. The mean goes in the middle. The lines should not touch. So these continue on, but they don't touch. And your mean would go in the middle. The mean was 66.41. And then they break it up. I think in another section, we get into more of the percents that are under the curve. But this is your units that you count by as the standard deviation, which would be 4.4. And so we'd be counting by 4.4. But for this section, they're only showing you that 95% of the values land between two standard deviations. So 95% of the heights will be between two values. To find those two standard deviations, you take your mean, you subtract point, oops, not point, two standard deviations. Standard deviation was 4 point. So I'm taking the mean and I'm adding and subtracting two standard deviations. 95% of the heights are inside that. I'm going to round one decimal place. Ninety-five percent of the heights are between 57.6 and 75.2 inches. If we do get into it, 68% is within one standard deviation and 99% is within three. But for right now, just the 95%, because that's the majority of your data. Any questions on that? Okay. To do these on Desmos, if you don't have the data open, you might want to open it if you're going to try it on Desmos, unless you're just going to watch. I'm gonna go to the data. It's this one. And get rid of the period here. Okay. Now, to find the mean, the standard deviation, you can even find the 5-number or the box plot quartiles, standard deviation. To find those, you need the list. Now, instead of having to enter that list into every piece of data, you can make a list. L equals, and then square bracket. Now I'm going to bring my data up. You want to highlight your data, and you can have it separated by commas. Online, it said spaces also work, but I had already had this in commas. You highlight it, Control C, and then left here, Control V. And it has our 25 elements. If we want to find the mean, go to Functions, Statistics, notice mean, median, the smallest value, the largest value, quartile, standard deviation. No, there's 2 of them. One is a standard deviation for a sample, which is just about everything we'll do. The other one is standard deviation for the population. And I don't think we'll get into these other ones. So let's find the mean. Mean, and then put your capital L, and there's your mean, 66.408, which is exactly what we got. Now, standard deviation, that was an estimate. So I'm not sure how close it'll be, but you do want the standard deviation of the sample. And we had gotten 4.4. Let's try the population one. Yeah, it's even lower, so. We had 4.4, which is definitely a high estimate. But there's our mean and our standard deviation. We talked about box plots, the box and whiskers. This does a pretty nice box and whiskers. It's under visualization. We have box plot. No, this is the height you want, which I think 1's probably a good height. Count by 1s. I'm not sure what the offset does. I don't know. Let's find it first, because notice it's not here, but the values were high, and this is only going up to 6. So we need to zoom. There it is. Over, spread out, and there it is. Smallest value, largest value, median, lower quartile, and upper quartile. Any questions on that? We could also do a histogram. Dot plot, that wouldn't work well with this data. Histogram. This is your width. If you wanted it wider than 1 unit, you could do that. But I think that's good. Now, when it does the histogram, it decides what to go by. this went by ones. We could have went, what did we go by? 3, I think. And you change the 1 to a 3, and now it looks more like our graph. So this width is whatever you're counting by. They went by ones. We decided 3s. Any questions? I don't know of any other graphs. If you're finding the quartile on here, whoops, I didn't go down to the next group. I think you have to put comma 1. Yeah, there's the lower quartile, Q1. The upper quartile is the third quartile. Because this is the first, the second is the median, this is the third. And if you look at what our values were for the lower and the upper quartile, 63.6, 69.5. Any questions? Positive? I think that's. This will also do natural logs and logs if you needed to instead of using your calculator. Any questions? Okay. Section 5.2 is probabilities and predictions. Go ahead and read like the beginning of it. Like a lot of it's reading, and then I would rather have you read through it first and then I'll explain it. But is there any questions on anything from this other the last section? Any questions? Good. Okay. Little easier than what we were doing before. Although the next section, sometimes probabilities can get confusing. So I think if you read it first and then I explain it, so you're seeing it a second time, it might be easier.
I think this is a
But is
lot
there
more.
any questions on 5.1? Any questions on the project? Okay. If you do not have any questions, then I'm gonna let you go and have a nice day.